The next important topic in this subject is something called network topology. So, it is also popularly called as graph theory. Now, what is this network topology or what is this graph theory? Again, let us split these titles into two parts. Okay, one is network, other one is topology. Now, what do you mean by network? Just now I told you interconnection of several varieties of elements, I mean varieties of circuits together. I call it as a network. Here comes topology. What do you mean by a word called topology? Topology is a branch of mathematics which it deals with the geometry of the network or the shape of the network or the geography of the network. Okay. Now, what exactly are we going to see in this network topology? Let me explain you in a simple way. For example, you might wonder, what is this topic all about? I'll simply say that there is nothing much difference between chapter 2 and chapter 3. It means there is nothing much difference between steady state DC circuit analysis and this graph theory or network topology. What did we do in second chapter? We took different varieties of circuits and we analyzed it. Analyzed means what? Finding out currents and voltages. As you all are aware, throughout this subject, we are going to see only two questions again and again. They are find current and find voltage. Fact is, current can be found from KCL and voltage can be found from KVL. So, KCL and KVL are the two powerful fundamental tools for you with which you can calculate currents and voltages. Now, so we analyzed DC circuits, I mean we calculated currents and voltages by writing KCL equations, KVL equations, etc. Now, when it comes to in this chapter also called network topology or graph theory, we are going to analyze the same circuits or same networks but in a different style, right? So, the method what we follow to analyze in this chapter is different and the method what we are going to analyze to the same circuit is going to be a little bit different, right? So, end of the day, here also you are going to analyze, means here also you are going to write same KCL equations and same KVL equations in a different style. Now, first let us try to understand what is the meaning of a word called graph. What is a graph? Graph is a pictorial representation of any electrical network in which all elements are represented with either straight lines or curved lines. To be precise, all passive elements, I mean resistor, inductor, capacitor, they are represented with either straight line or curved line. But when it comes to two sources, that is your voltage source and current source, voltage source must be represented with short circuit and current source must be represented with open circuit. Why? Because whenever you are replacing the sources, you have to replace them with its internal resistances. Therefore, let me give you one simple example. Consider a simple network. For example, I am considering all the common elements. So, let us say there are 4 nodes A, B, C, D. These are the branches, branch 1, 2, 3, 4, 5 and 6. Okay. Now, this is something called a network. Now, I am going to draw its equivalent graph. Okay, before that, let me consider some current directions. Let's say the current directions are like this. I am just taking these current directions randomly. Okay. Now, this is something called a network. Now, I am going to draw its equivalent graph. Here comes. What is a graph? Graph is a pictorial representation of an electrical network in which all elements are represented with either straight lines or curved lines. Now, I am going to draw its equivalent graph which looks something like this. Now, I am going to draw its equivalent graph. As I said, what is a graph? It is a pictorial representation in which all elements are represented with either straight lines or curved lines. When it comes to sources, voltage source must be represented with short circuit and current source must be represented with open circuit. So, in short, out of 5 elements, voltage source, current source, resistor, inductor and capacitor, 4 elements are to be represented with either straight line or curved line. But when it comes to those 4 elements are of course voltage source, resistor, inductor and capacitor. When it comes to current source, please represent it with open circuit. Representing current source with open circuit is nothing but what? Represent it with nothing. So, one point, very important point to be remembered is whenever you are trying to draw a graph, first and foremost thing, my sincere suggestion, what you do, please check any current sources are there in the given circuit or not. Because in a hurry, what you will do, you will also replace current source with a straight line or a curved line, which will mess up your answer. So, please check whether you have any current sources or not. If there are no current sources, then confidently and blindly replace every element with either a straight line or curved line. So, now I am going to draw its equivalent graph, which looks, this is branch 1, branch 2, branch 3, branch 4, branch 5 and branch 6. Alright. So, these are the directions. Okay. Now, this is an electrical network and this is going to be its equivalent graph. Of course, these are the nodes, node A, B, C and D. So, this is an electrical network and this is going to be its equivalent graph. Now, what exactly can we observe from the graph? Graph gives you the physical structure of the network. Graph gives you the skeleton of the network, or in fact the graph gives you information about what? The geography of the network or the geometry of the network. So, having a look at the graph, you can understand how many number of nodes are there, how many number of meshes are there, how many number of loops are there, how many branches are there between this node to this node, how many number of branches are connected, or so and so branch is connected between so and so node to so and so node, and what is the direction of some so and so branch current in a particular network. So, this complete set of information you can easily understand from something called graph, right? So, this graph theory is such a kind of mathematical tool which don't care about or which does not care about the type of element or the nature of element. It only cares about its physical connection. That is the reason no matter whether it is a resistor, inductor, current source or voltage source, it will be replaced with either a straight line or a curved line. That's the reason we are calling this as network topology. Means it is such a kind of mathematical tool which deals with only the physical connections of the network, which does not care about which we are least bothered about what type of element it is. Okay. Now, in this chapter, initially we are going to learn what is a graph, how to draw a graph, how many types of graphs are there, what are its properties, etc. And most importantly, we will be learning what is the importance of this graph or what information can we capture about this graph is what we are going to see. Once we are done with this, then we will be moving on to our next and most important topic called incidence matrix. Now, what is incidence matrix? Incidence matrix, the information related to a network can be neatly represented in the form of a matrix, and this matrix is called as what? Incidence matrix. So, by simply having a look at the matrix, I can understand major portion of information about my network. So, by looking at a graph, I could see or I could understand some things about my network. Similarly, by looking at an incidence matrix also, I could see some interesting facts about my network. So, looking at these two things, graph and incidence matrix, I will be able to visualize how my network looks like. And once these two things are in front of me, then I can start my analysis. Now, incidence matrix, how to, in this chapter, as I said, we are going to construct incidence matrix, how to construct incidence matrix, what are its properties. We are going to learn two things. One is how to develop incidence matrix from a graph and how to develop graph from incidence matrix, reverse engineering. So, we are going to learn both the things. Once we are done with this, we are going to learn about two more matrices, that is a tie set matrix and cut set matrix. So, what is a tie set matrix? So, again, initially we are going to learn how to construct tie set matrix, and most importantly we are going to learn what information can we capture from tie set matrix. So, in the second chapter we used to capture information about the network by looking at the elements, by looking at the network, by looking at the circuit. But in this chapter, we are going to do the same analysis, but we are going to do it in a different style. Means we are going to analyze, we are going to write same KCL equations, same KVL equations, but in the second chapter, we wrote the equations by looking at the network, but here we are going to write the equations by looking at the matrices, in fact. Right. Most importantly, we are going to write KCL, KVL equations, or any finding out the branch current equations, branch voltage equations. All these equations we are going to write by looking at the matrices. So, in this chapter, the major part or the major topic is formation of these three matrices, that is incidence matrix, tie-set matrix and cut-set matrix. As I said, initially we are going to learn how to develop these matrices, and later on how to capture information or how to write KCL, KVL equations, or how to find or how to write down the branch currents and branch voltages equations from the matrices is what we are going to learn. Trust me, this topic is one of the very simple topic, provided you understand some tips and tricks. Once you know those tips and tricks, then things will become very easy in solving any question related to graph theory.